So in lecture 6, we will discuss mainly the asynchronous counter design, and how we can design the up and down counter using JK and T and D flip-flop. Okay. And we can also describe the operation of asynchronous counter and how we can draw the timing diagrams. So before going to the counter part, already we discussed there are two types of counter. One counter is known as asynchronous, another type is known as synchronous. In synchronous counter, the different flip-flops and circuits are clocked by using the same clock. Okay. The same clock signal is applied to the different flip-flops available in that particular circuit. But in the case of asynchronous, the clock signal is only applied, that is, the external clock signal is applied only to the one flip-flop, and remaining flip-flops is clocked by using the output of the first flip-flop. So either Q or Q bar can be connected as a clock of the second flip-flop and the remaining flip-flop. So here you can see the main difference between asynchronous and synchronous. In the case of synchronous, the same clock is used, but in the case of asynchronous, the clock is applied only to the one flip-flop, so the first flip-flop, and then the output of the preceding flip-flop is connected to the clock of the next flip-flop. Okay. Either Q or Q bar is connected to the clock input of the next flip. So when you design a asynchronous counter, here I will give you some tricks to design a synchronous counter. Okay. Normally we will use the flip-flop in the toggle mode. Okay. And here you can see the JK flip-flops taken as the example. In order to get JK output in toggle mode, JK input should be connected to high. Okay. If you are using T, again T input should be equal to 1. And if you are using D, we need to some tricks in that we will discuss later. Anyway, remember that the JK or the input of the flip-flop should be in the toggle mode. Okay. That's one point you should remember. And I'll tell you how we can design up and down counter. For example, if you are using a negative edge triggered clock, okay, and the Q output is connected as a clock. For example, this is a negative edge triggered clock, and this is also negative edge triggered, and the Q output is connected to the clock. So the first one is directly connected to the clock input, and the second flip-flop is triggered by using the Q. So here you can see the negative edge triggered and Q as a clock. So it will operate as an up counter. And here you can see another possibility. If the clock is again negative, so negative edge triggered clock is used, and the Q bar output is connected to the clock input. So then that particular counter will operate as a down counter. And now we'll discuss another possibility, that is the clock signal is positive and the Q output is connected. Okay. So that is, here it is positive, then it is known as a down counter. And another possibility, this clock signal is again positive, but we are connecting Q bar to the next stage. So then it is operate as a up counter. So here you can see that if this is a negative edge trigger and Q is positive, and here it is negative and Q is negative, Q bar we can consider as a negative. Now here it is positive and Q we can consider as a positive. So here it is positive, this Q bar, so we can consider as negative. So you can see that when the same sign comes, that is negative, negative, okay, and positive, positive, the counter will be in the down counter. And when the negative and positive or positive negative, that is the opposite sign, it will operate as a up counter. So this is an easy way you can or you can consider as a trick to design an asynchronous counter. Okay. Now we'll discuss the first one, the 2-bit asynchronous counter. This counter is also known as a ripple counter. So asynchronous counters are also known as ripple counters. Okay. So either they can ask 2-bit ripple counter means you should design an asynchronous counter. Here we need up counter. So if it is an up counter uh, and the clock signal is a positive edge triggered, okay, so this is a positive edge triggered clock, and we required up counter. So we should connect a Q bar to the clock signal. So you can see that Q bar is connected to the clock. And the JK inputs are connected to high, means JK inputs are 1 1. So JK inputs are 1 1 means it's in the toggle mode. So it will complement the output. So this is a input signal, and this is a positive edge triggered clock signal we are using. Now we can see the output waveform. So assume that this is a clock signal. The same thing here you can see. So we are using a positive edge triggered clock. And now we can analyze Q0. So, and one more point, if there is more than one flip-flop, we need to identify the LSB and the MSB. And we can identify the LSB very easily. LSB will be the flip-flop where we are applying the clock signal. So where we are connecting the external clock, that flip-flop will be the LSB. So here it's connected to flip-flop 0, that is Q0 will be your LSB. So that's why here it is written Q0 is LSB. So assume that Q0 is initially 0, okay, initially 0, and at positive edge. So at this particular instant, Qn is equal to 0, and we need to find Qn plus 1. After applying the positive edge trigger, you need to find Qn plus 1. Here JK inputs are 1 1 because it is connected to high. So Qn plus 1 will be Qn bar. So it becomes 1. So 0 is changing to 1. Now it will continue in this particular state, and when it reaches the next positive edge triggered clock, again we need to verify the output. So JK inputs are again 1 1, and here Qn is equal to 1. After this clock signal, Qn plus 1, it becomes Qn bar. So initially it is 1, so now it is 0. So now it is changing to 0. Again on the third clock pulse, Qn is equal to 0 and JK inputs are 1 1. So we need to toggle. So Qn plus 1 is equal to Qn bar, which is equal to 1. So the output becomes 1. And during the fourth rising edge, JK inputs are again 1 1. So Qn is equal to 1 here. So Qn plus 1 will be equal to Qn bar, because JK inputs are 1 1 means it's toggle 1, so it will get 0. So it will be like this. Okay, I think it's clear. Now we'll move to the next part, that is we required Q bar. So what will be Q bar? So if you know Q0, it's simply Q bar will be the opposite of this particular wave. Okay, so Q bar will be like this. If it is Q0 is 0, it will be 1, and if it is 1, it will be 0. If it is 0, it will be 1, 1, 0, 0, 1. Okay, it's just opposite of Q0. Now we need to identify the Q1. Okay, what will be Q1? Here you can see the JK inputs are connected to high, and the clock signal is Q0 bar. Okay, it's very important. We don't want to consider this particular clock, because for the second flip-flop, that is flip-flop 1, the clock signal is Q0 bar. So we will consider Q0 bar as the clock signal for flip-flop 1. Okay, so we don't want to consider Q0 and this particular clock. Okay, so now we can see that this is a clock signal. Q0 bar is the clock signal, and we are using a positive edge triggered clock. So this is a positive edge, and this is a positive edge. So assume that Q1 is initially 0, so it is 0. Now when it reaches the positive edge of Q0 bar, okay, we need to identify the Q1 output, because J1 K1 is equal to 1 1. So here it is Qn is equal to 0, then definitely Qn plus 1 is equal to Qn bar, which is equal to 1. So output is changing from 0 to 1. Now it will continue in this particular state, and we will observe Q0 bar as a clock. So next positive edge occur at this particular instant. So again we need to verify the J1 K1 input at this particular time. It is again 1 1. It's fixed. So Qn is 1, and qn plus 1 will be qn bar, which is equal to 0. So now we can see that the input is, sorry, q1 is changing from 1 to 0. So this is a final waveform. If you observe q1 q0, so q1 is one output line, q0 is another output line, and q1 q0, q1 is MSB. So it is 0 0 initially, now 0 1, and it is 1 0, and 1 1, again it is 0 0. So you can see that initially it is 0 0, after that it is 0 1, and then 1 0, then finally 1 1. Again it repeats the particular sequence. So 0 1 2 3 0. So it will act as an up counter. So already we know that if positive edge triggered clock is used and Q bar does the clock, so we know that it is an up counter. Now we'll discuss a 2-bit synchronous up counter by using T flip flop. So the only difference here, we are using instead of JK we are using T. So if T is equal to 1 means it is again a toggle mode. Okay, the output will be complement. And here we are using a negative edge triggered clock, not positive. It's a negative edge triggered clock, so it's negative edge triggered, and Q output is connected to the clock input. So Q. So one is negative, another one is positive. So definitely it will be an up counter, and we can verify that also. So instead of JK flip flop, we are using T flip flop. So now we are using a negative edge triggered clock. So this are the negative edge point of the external clock. External clock is supplied to the first flip flop, that is flip flop 0. So we need to identify Q0 initially. So Q0, you can see that, assume that initially Q0 is 0, and when it reaches the first negative half cycle, you can observe that T is equal to 1 because T is already connected to high. So it's in a toggle mode. So Qn is equal to 0. So Qn plus 1 is equal to Qn bar, which is equal to 1. So output is changing to 1. This is the next point. Next instant, here Qn is equal to 1 and T is equal to 1 at this particular instant. So Qn plus 1 equal to Qn bar, which is equal to 0. So again negative half cycle, again it will complement 0 to 1. Okay, this is another instant, this is another, again it will change. Okay, so we got the Q0 output. Now we need to check Q1. So in the case of Q1, we need to find out Q1. So for that we need this particular clock, and this clock signal is Q0. So now we need to consider, so don't consider this clock. So Q0 will act as a clock signal for the Q1 output, and negative edge triggered clock we are using. So this particular instant will act as the falling edge clock. So initially assume that Q0 is 0, it will continue in that particular state, and when it reaches the negative point or the falling edge of the Q0, we know that T is equal to 1, T1 is equal to 1 in this particular point, and Qn is equal to 0. So Qn plus 1 will be Qn bar, which is equal to 1. So output is changing, Q1 is changing from 0 to 1, and when it reaches the next Q0 1 to 0, when there is a transition from 1 to 0, again it will observe the T1 input, which is equal to 1. So Qn is equal to 1 at this particular moment. So after this clock, Qn plus 1, which is equal to Qn bar, which is equal to 0. So now we can see that initially 0, then 1 0. Now we can observe the Q1 Q0 change. Initially it is 0 0, then it is 0 1, then 1 0, and 1 1. Again it repeats. Okay, so here you can see the counter output. Now we can discuss a 3-bit asynchronous down count. Already we identified that this will act as an up counter. Now we can see that this is an up counter. Now we'll discuss a 3-bit asynchronous down count. Okay, again by using T flip flop. So in this particular diagram, you can see that the clock is positive edge triggered clock, and Q output. So you can see that both are positive, so definitely it will act as a down counter. Now we can verify this particular circuit. It's a 3-bit, so we need to use 3 flip-flops. And the LSB is Q0, and the LSB is Q0 because we are connecting the external clock to this particular Q0 flip-flop. Okay, so this is T0, this is Q0. We can indicate T1, Q1, Q1 bar, T2, Q2, Q2 bar. Now we can see that it's a positive triggered clock, so we can indicate the positive edges of the clock. Okay, these are the positive edges of the clock. Now we can observe Q0. See, initially assume that Q0 value is 0, assume that Q0 is initially 0, and when it reaches positive half cycle, it's in the toggle mode, so output goes to 1. Again, it reaches next clock cycle, positive edge. Again, T input is 1 always, so, or you can say T0 is 1 always. So again it will toggle. Again during the next clock, again it will 1. Again during this particular instant, again it will complement. Again it's 1 during this particular duration. Again this duration it will complement. Again this duration it will complement 0, 1, etc. Okay, so it will continue like this. Now we need to observe the Q1 output. So this is the Q1 output, and this is the T1 input, and here the clock signal is Q0. So you don't want to consider this particular clock. Q0 will act as a clock. So this is a positive edge triggered flip-flop, so you need to identify the positive edges of Q0. Now you can see that during this particular instant, initially Q1 is 0, so, and T1 input is 1. Okay, T1 is connected to 1, so it's a complement board, so 0 will change to 1. Next, again at this particular instant, Qn is 1, so Qn plus 1 becomes 0. Okay, it will continue like that. Again, next positive edge triggered. Initially, the input is 0, so it's in the toggle mode. T is equal to 1, so it will complement to Qn plus 1 will be equal to 1. Again, during this clock duration, again there will be transition. It will continue like that. Okay, now we can observe the third flip flop. Sorry, Q2. And this is Q2 and this is Q1. Now we can see that for the third flip-flop, we need to identify Q2 output. For this particular Q2, Q1 will act as the clock. Okay, so you don't want to consider Q0 or this particular clock, because Q1 is connected to the clock input of the third flip-flop. So Q1 will act as the clock. So two rising edge, you can see that. So output will change during the first rise. Initially output is 0, so T2 is already connected to 1, so it's always 1. So T2 is equal to 1, so output will be complemented. Qn plus 1 is equal to Qn bar, which is equal to 1. It will continue like that, and again it reaches this particular instant. You know that Qn is equal to 1, so Qn plus 1 equal to Qn bar, which is equal to 0. Again it's changing. So now we can observe the output Q2, Q1, Q0. Initially it is 0, 0, 0. Now it is 1, 1, 1. Then 1, 1, 0. 1, 0, 1. 1, 0, 0. 0, 1, 1. 0, 1, 0. 0, 0, 1. 0, 0, 0. So if you write Q2, Q1, Q0, okay, by observing this particular waveform, initially it is 0, 0, 0, then it is 1, 1, 1, then 1, 1, 0, next one is 1, 0, 1, and 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0. So you can see that 0, 7, 6, 5, 4, 3, 2, 1, 0. So you can see that's a down counter. We already mentioned that it's a positive edge triggered clock and Q output. Okay. Now we'll discuss one more circuit in this particular asynchronous direct implementation. So here also you can see that trailing edge of the clock means it's a negative edge triggered clock. So all these clock signals are a negative edge, and here we are using D flip-flop. So we know that for the D flip-flop, if D input is 0, okay, your Q will be 0, okay, during the clock cycle. Let be negative edge trigger, okay, and corresponding Q bar is equal to 1. And when D input is 1, Q is equal to 1 and Q bar is equal to 0. So in order to get a toggle mode, there is no option. So one way we can connect this flip-flop to operate as a toggle mode, just connect Q bar as the input of D. See, if you apply 0 and when there is a clock, the output will be 1. So 0 becomes 1. Now we are fed back this 1 to the input side, means during the next half cycle, next clock cycle, the D input is 1. So definitely Q will be 1 and Q bar will be 0. Okay. In this way, you can change the D input and Q bar output. So it is continuously changing 0 to 1 and 1 to 0. Okay. Now we can, so this configuration will act as a toggle mode. That's all. Remaining operations are same. Here we are connecting negative edge triggered clock and Q bar is connected. Okay. So not Q bar, so Q connected to clock. So opposite side means it will act as an up counter. Okay, Q is connected to the clock signal, and clock signal is negative edge is already mentioned. That is trailing edge means negative edge, or you can call it as a falling edge. So these are the sensitive points. Okay, falling edge. So Q0, first we need to identify Q0. So at this particular instant, negative edge, Q0 is 0. Okay, so if Q0 is 0, definitely Q0 bar will be 1. If Q0 bar is equal to 1, means D input should be equal to 1. If D input is 1, after this particular instant, the output is equal to 1. And during the next clock cycle, when D is equal to 1, okay, and if you apply the clock signal, okay, here it is 1 and here it becomes 0. So again it will change. So in this way it will operate, and for the next cycle Q1, Q2. So you can see that 0, 0, 0 and 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, and 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, now 1, 0, 1, 1, and next one 1, 1, 0, 0. So in this way it will continue from 0, 0, 0, 0 to 1, 1, 1. Okay, just like Q3, Q2, Q1 and Q0. So this is general procedure to find the design of asynchronous counter. Okay, so we discussed the JK, T and D, up counter and down counter.